welcome. This is Dr. Hisham Saeed. This is the third part of a very condensed series on construction cost estimate. So this part here we're talking about rough order of magnitude estimates. And this is one of the early type of estimates that are done in the project life, where the owner comes to you as either an engineer or a construction consultant or a construction project management company, and they ask you, what do you think if I build this project? So typically, like, developers want to calculate the return on investment, right? So if I build this fancy hotel in this area, what's my return on investment? So I first need to know my investment, and they have their own, stuff they do to calculate the return or expect the return. So they figure out the ROI here. But you need to know how much investment I need to put in, or the cost of this building will be. So without a design, you can't do a detailed estimate, so you need to do a rough order of magnitude estimate. And you do that doing the cost calculation based on an attribute of the project to represent its size. So in buildings, we use floor area. In highways, we use length. So the cost can be how much dollar per mile, or station. So highways are measured in stations or miles. Or if you're dealing with manufacturing facility, dollar per production volume. So if you're producing this number of pieces, then it will cost you this amount for the factory or assembly line. So there are many ways you can do rough order of magnitude. There's an empirical formula, so kind of you drive it based on the previous historical data, or you can use square foot estimates from your previous experience or published references. So this is what we're going to do, square foot estimates. So we use a square foot estimate and rates from books and references that are published, or you can look at, if you're in a company that have been in business for many years, you can go back and try to analyze the database of costs you have. And it's kind of the references that the one that you will use, which is RS means. The RS means square foot data are organized by the type of the building. So you cannot say square foot cost is the same for all buildings. Every building is different. They have different building systems. They have different features. So you need to categorize the projects that you have into buckets, and every bucket or group will be unique by a square foot cost. So the total cost of the project, TC, will equal to two things: above ground and below ground, because below ground is a very different animal to deal with. It's very different construction methods, very heavy in terms of cost. So the rates here are different. And also the decision to have a basement or not is a very strategic decision in the beginning of the project. So you need to split having a basement from how many floors you will have above ground. So the first term here is the gross floor area. So the floor area here, FA. So you need to multiply the floors by the square foot of every floor. You get the floor area, the total floor area of the building. You multiply this by the floor square foot cost. So how much of every one of these floor square foot will cost you from the data we have. And then similar thing will be done for the basement. And then you will adjust the costs here by adding any additive or additions that were not part of the models that you're following, or the standard models for these square foot cost rates that you use. So RS means square foot book has different pages. These pages are organized by different models of buildings. So you can see here the code here, M09140. So they're organized by different classes of buildings. There's college buildings, there are community centers, computer data centers, different types of buildings. And for everyone, you have two pages. One is showing you kind of the kind of a cover sheet, shows you the big overall numbers of different cases. And the second page shows you an example calculation of one of these numbers. So if you want to relate to the formula I presented before, this is the floor square foot cost, and this is the basement square foot cost, and this is the additives that you will add to the formula, or the two main components you have. And then the second page here is showing you a detailed calculation of that specific square foot of that specific case of the building configuration. So let's dig deeper here. Focus on the first page, the top half of it. So how to use this table to get these square foot floor square foot cost rate. First, you need to kind of get an idea how the building will look like. So you need to first understand from the owner how much total square foot of the building. Again, it's the total for all the floors. And then get an idea how the shape of the building will be. So the perimeter is another number. And the R's means they did here, they kind of classified generally when you have, let's say, a 50,000 building, they expect on average it will be around 433 perimeter linear foot. So they kind of trying to put the apartment buildings of 4 to 7 stories in kind of typical looks. So you try to see which bucket you are in, which type of building you're in, which size of building, which shape. Question to you, when do you think that this perimeter will be different for the same area? So it's actually a geometry question. So I will leave you to think about it. So can I have the same area or gross area of a building but with different parameters? It's a very simple geometry question, but think about it. I will not answer in the video. We'll discuss in the class. The second thing you need to know from the owner is kind of the structure system. So what type of, is it steel or concrete? And also the facade. What's the exterior wall selection here? Are you talking about curtain wall, brick wall, precast panels? So once you identify the size of the building and the look of it, the features, the outside features, and the structural system, you'll be able to pin down the number that represent the square foot cost estimate, cost rate. This is the basement cost rate, and this is an adjustment, so values for adjusting for two main things. Adjusting for perimeter, so let's say you have a building 50,000, but your perimeter is 700 instead of 433. How to still use the numbers that are given to you, but still, make some adjustments here. So for every 100 linear foot of perimeter extra, you need to add to your square foot cost rate this way or this way. Also, you need to adjust for the height. So in the second page, which shows you here the detailed calculation of one of the numbers of first page, you can see the description here. That's a 10 foot 4-inch story height. So the height of the every floor is this number. Now let's say the design came up to be like the owner want to have like high ceiling, very fancy building, then it will be like 12 feet. Then you have around 1 and 2/3 of a feet difference. So then you will go back to this table and say for every 1 foot difference of story height, I need to adjust again, add to the square foot cost this additive. So this is just an example calculation. It's good to see it how it's being done. So, and also we start from the bottom here. These are only costs. So we will learn in detail estimate that price of a building, because an owner goes to the contractor to build, not for the cost of the price. So price equal to the cost plus a lot of overhead and fees. So here you account for fees for the architect and the contractor, and then this is all the kind of the numbers and rough kind of calculations that add up to the big number that we have here, $183.4 per square foot. And one thing here you will notice that we are following here the assembly uniform mat classification. So A, B, C, D, if you go back to the first part of the series, uniform mat versus master format, square foot estimate is based on uniform mat, not master format. So if I zoom in, let's make a sense of numbers here. So you have here standard foundation. This building is assuming standard foundation, poured, strip, and spread footings with 4 feet foundation wall. The unit of measuring that scope of work or this assembly is square foot ground, meaning that the footprint of the building you don't multiply by the floors. And the unit cost of that foundation system is 8.4 per square foot of the footprint of the foundation. But remember, the cost square foot that I'm using to build up my estimate for the project is per the gross total floor square foot. So what happens here is you divide this 8.4 divided by the number of stories. So you have here 6 story or 6 floors. So you end up with 1.4. It makes sense for another thing. So exterior doors, you have aluminum and glass single and double doors. It didn't say how many, but actually I can verify that. So each door costs $5,475, which translates into $0.55 per square foot. Remember, dollar per square foot. I have here 60,000 square foot. This is all this area on six floors. So I multiply the square foot rate of the doors times the total area, and then divide by the costs of every individual door, and that will give me 6 doors. So now I know that the model here is based on 6 exterior doors. So just examples here to show you can make sense. You can kind of reverse engineer the values and see what assumptions were used in this model of square foot cost. So let's see an example here from the beginning. You're working in an engineering consulting firm and you're trying to estimate a 7-story apartment building. The building is a rectangular shape with these dimensions here. Building has 1-story basement and you remember 7 stories above ground. Total area of the building, of the basement is 4,200 square feet. The building will be built with steel framing. Your story height or the height of every floor is 11 foot. The exterior walls will be brick veneer, except for the north side, which will be covered by curtain walls. Curtain walls are a little expensive, so you put them usually in the front of the building. And that's it. We want to calculate rough order of magnitude estimate here. So the first thing is you want to calculate the footprint of area of the building. So it's multiply the length and width. You end up with the area here. So the floor area, multiply this footprint times the number of floors, end up with around 80,000 square feet. The perimeter with geometry of rectangle, you end up with 500 feet. If you look at the table here, again, match the description of the building to which page in the ours means a square foot book. And you see here it's matching with this column here. So it's around 80,000, 500 feet. Yeah, 500 feet is not that big difference from 530, especially that the adjustment for perimeter is per 100 linear foot. So if you want to really be punctual here, you can actually do kind of adjusting for that, but for simplicity here, we'll say it's roughly the same. So I will do approximation here. Now for picking which number of these, it depends on the configuration of the building. The structural system, it's rigid steel, but some part of the building is covered by curtain wall, but the one side of it, but the rest of it is brick veneer. So which number should I use of these? The idea is to use weighted average. So you will calculate the percentage of the wall, the exterior wall of the building that's covered by curtain wall. So how much of the facade is covered by curtain wall? So that's around 38%, and 62% is by brick veneer. So now 38% times the square foot related to curtain wall plus 62 times the $169. So you will end up with a weighted average of 172.3 or $2.26 per square foot. So now I interpolate between curtain wall and brick veneer using kind of a weighted average calculation. Now I need to make any adjustments to that. So I need to adjust for the height, because I see here the building is the model here, the model square foot that I have in the book is 10 foot 4 feet, but 10 foot 4 inch. But the case I have is 11 foot 4 inch. So there is 1 foot difference. And for every foot difference, I have here 2.4 extra dollar per square foot. So this means I need to adjust here my square foot to be that. And then the basement, I need to add 39.2 per square foot for the basement I have. So I have here 39.2 per square foot of the basement, not of this 80,000. So the basement has a 4,200 area, not 11,460. So just to make a difference, the basement is not covering the whole footprint of the building above ground. It's just a part of it is just the basement. So now I multiply every area to its corresponding square foot above ground, below ground. I end up here with the total cost. So that's the total cost of the project based on the brief description that I have from the previous slide. This is basically all the information you have. But once you have you go through the design exercise and get more design information, then you will be able to refine this cost estimate by more detailed type of estimates, like assembly estimates, and then all the way until you do the bid estimate. So that's the end of this lesson. It's introducing the idea of developing a rough order of magnitude. Many ways of doing that, but in this course here, we're focusing on the square foot estimate. We'll learn how to use the RSMeans square foot book, get familiar with its pages. Remember, always rough, and from its name, it's a rough order of magnitude estimate. So you expect a margin of error here a little big, and that's the nature of it. You're just given a brief description of a project. So look forward to the next part where we talk about detailed estimate, and that's a whole different animal, different process to go through. So until then, take care of yourself and those around you.